Next topic is dimensions. So there are three terms, similar terms: dimensions, dimensional formula, and dimensional equation. All three terms are kind of similar. We will understand all of these three terms simultaneously. So first let's understand what is the dimension. I will explain you with an example. Let's suppose you know velocity. Velocity is a fundamental quantity or a derived quantity. What is that? It is a derived quantity. So if I want to calculate, let's suppose I want to calculate the SI unit of velocity. To calculate the SI unit of velocity, I will need a formula of velocity in the terms of the fundamental quantity. So the velocity is distance divided by time, or displacement divided by time. Let me rewrite. It's displacement divided by, now displacement is measured in the meters and time is measured in the seconds, so that's why the SI unit for the velocity would be meter per second. We have done these kind of things. Here, instead of getting the formula, if I can define something kind of dimensional formula, where this dimensional formula gives me dependency of the velocity, dependency of the velocity on the displacement or and time. Or basically what I want to say, if I define a formula that gives the dependency of the derived quantity on the fundamental quantity, then you can say that that formula is dimensional formula, and that dependency are called as dimensions. So let me write it: dependency fundamental quantity of of a derived quantity on fundamental quantity. So you know what are the fundamental quantity? There are 7 fundamental quantity. So any of the quantity will be dependent somehow on these fundamental quantities. So that dependency of the derived quantity on the fundamental quantity is called as the dimensional formula. So this is the dimensional formula. Of course, from this definition I cannot understand what is exactly mean by the dimension. There is one more definition which gives kind of accurate or the precise definition for it. You can say that the exponent or the power of fundamental quantity in the formula of derived quantity is called as the dimension, and if we write down that dimension in the formula, then it is called as dimensional formula, and if we write down in sort of equation, then it is called as dimensional equation. Let's again understand it with the same example of velocity. So velocity is dependent on the fundamental quantity, and these quantities are displacement. So displacement is on the numerator and the time is in the denominator. So now from here you can say that I want to write down the dimension, let's suppose the question is write down the dimension of the velocity. So then I will say that there are 2 fundamental quantity, displacement and the time, and displacement is basically the length, this is the length, and time is time. So I can say that the dimension of length in velocity. Okay, now velocity, the velocity formula is a displacement divided by time. Displacement is in the numerator and displacement is only one time. That's why you can write down the displacement as a displacement to the power 1. And that this exponent, you need to understand it very carefully. Sometimes it seems like it is very new concept and you may be hearing it first time, but it is not like that. It is very much related to the units, and in the coming lectures we will understand how to use this dimension to derive the units. So when you get familiar, it will not look like a something very abstract from this chapter. It is very basic to the chapter. So let's again understand it. So dimension of the length is the velocity. So length is in the numerator and the power is 1. Now what is the definition of the dimension? Exponent or power of the fundamental quantity in the formula. What is the exponent? 1. So that's why you can say that the dimension of the length in the velocity is 1. So probably you are understanding what I'm trying to say here. The next, the dimension of second is time in velocity. Now problem is this time is in the denominator. So if I take this time in the numerator and the power will be -1, I can write down the velocity as displacement multiplied by time to the power -1. Is there a problem with it? No. Now tell me, what is the exponent? -1. So that's why dimension is -1. So it's a quite easy problem to calculate, right? Okay, let's take one more example just to understand. One more thing before going on to the next example. I can also write down the dimension of what is the third fundamental quantity? Mass in velocity. Now is there any mass? No, but still can I say that mass to the power 0, because anything to the power 0 is always 1, and we can multiply the displacement and the time with the 1. There will not be any change in the formula, right? So that's why I can say that the dimension of the mass in velocity is 0. Similarly, I can say for all remaining fundamental quantities, the current, the temperature, the luminous intensity, right, and the amount of substance, all of them, the dimensions are 0. So this, from here, what do we understand is that I can understand the dependency of the velocity. So if I change the temperature, will there be any change in the velocity? No, at all. Why? Because the velocity is not dependent on the displacement, it's not dependent on the temperature. So that's why it's important to understand the dimension, so that we can understand, okay, what are the factors that will affect the quantity. So that's why it is defined. Now the problem is that writing like this again and again is not a easy task. So that's why, to reduce this kind of thing, what we are doing is we are defining the dimensional formula. So to write down the dimensions, you need to use so many segments. So to reduce that, what we are going to do is define a dimensional formula. Okay, so it will be kind of formula which will be having all the necessary things which are in the dimension. So let's suppose if I represent the length with L and the time with the T, okay, can I say that the dimension of velocity, dimensional formula of velocity, is L to the power 1 and T to the power -1. Okay, but the problem is that you want to write it down like a formula, and there may be next thing you may be writing somewhere here. So when you just read it, you may get messed up with this stuff that is written here. So that's why what we are going to do is that we will close it in the brackets, in the kind of square bracket. So this is the dimensional formula. So it's not a kind of uh, something rocket science. It is very easy to understand what is the dimension, what is the dimensional formula, right? Now you may want to write down the length with the LE. Okay, you could have done if you were the scientist. So now what we are doing, we are fixing the dimension. How do you represent the dimension? So that again, these 7 fundamental quantities are there. So there are 7 fixed representation for the dimension of those particular quantities that you can write down in the formula. You cannot write down on your own something. So let's write down the list of the fundamental quantities dimension. So dimensions of fundamental quantities. Generally, when we use the dimension term, it is dimensional formula. So here I'm writing down the list. So for that, okay, yeah, these are the fundamental quantity. This side I will write down the fundamental quantities. And this side I will write down the dimensional formula. Let's better call it as dimensional formula. Okay, so tell me the fundamental quantity one by one. The mass, length, okay, time, okay, then the temperature, very good, then oh, next thing you forgot, that is electric current. Wow, very nice. Electrical current. Next is the amount of substance. Amazing. And the last one is, surely you don't remember that, that is luminous intensity. Wow. So probably there may be a mistake in my spellings, so just pardon me for that if there is anything. Okay, so first is mass. Now generally what we do is we are forgetful of everything, so that's why we will not use for the mass. I may use a scientist could, whatever who has designed, they could have used a, but they preferred it to keep it simple, so that's why they use the first term m. Remember, this is dimensional formula. We are going to close it in the bracket. Length, of course, it should be L. The time, of course, it should be T, right? Keep in mind, we are discussing the dimensional formula. I know what is going on in your mind is that you may be thinking like, okay, the time, the dimension of the time is second, bracket close. That's completely wrong. The length, meter, close it, and the mass, so you will get a perfectly 0 marks for it, right? So don't do it. Keep in mind, dimensions and SI units or units are different. We have discussed the fundamental quantities units, but don't get messed up with the units and the dimension. So gradually with the practice you will be getting to understand that what is the dimension and what is the formula. You will get the distinction between them. The temperature, okay, so now for the temperature you could use the K, okay, or theta. So generally we will be using theta, but sometimes because the temperature's SI unit is Kelvin, So that's why we also use the K. For the electric current, current is represented by I, so that's why this is mostly used, but that the electric current is measured in amperes, so sometimes some of them also prefer to use the A, but most of the times we will be using the I. And the next one is theta. Next one is amount of substance, again that is mole, and the next one is luminous intensity, and that is K delta Ct. So these last of them are having kind of the similar dimension or dimensional representation or dimensional formula, kind of their SI units. Okay, so now from here, just I will take just few minutes to explain you how do we calculate the dimensional formula of a derived quantity. Okay, and then in the next lecture we are going to practice these kind of problems. So dimensional formula of fundamental quantities. Okay, what are the fundamental quantities? Sorry, again I did the mistake. Dimensional formula of derived quantity. Yeah, because we have already discussed the fundamental quantity. Yeah, so let's take velocity we have discussed. Let's take the acceleration. Acceleration is represented by A. I want to calculate it. Acceleration is velocity divided by time. This is the formula for the acceleration. You know the dimension of the velocity. So now one important thing to notice here is that let's say there is some derived quantity, and that derived quantity is again dependent on some of the derived quantity, then you should know the dimension of that derived quantity to calculate the dimension of this derived quantity. Able to understand? If you don't know, then what you will do? Tell me. You are again going to get the formula of this derived quantity so that you can find out the dimension. And again, let's say in that derived quantity, in that formula of this derived quantity, this velocity, there is another derived quantity. Then again we will do the formula, do the calculation of the dimension of that, and then again calculate the dimension of the velocity, and then we will do it. So basically you understand the process. So velocity is displacement divided by time, so that's why LT minus 1. Now see, I cannot write down V is equal to LT minus 1. V is velocity is not LT minus 1. So because I am writing down the dimension, and this is the dimensional formula, I should either write down the dimensional formula, I should write down a statement like this, or I could use this kind of thing. So this means that the dimension of the velocity, right? And dimensional formula of the velocity is equal to the LT minus 1. So now when we equate two formulas, then this is the equation. So this is the dimensional equation. You are getting? This is the dimensional equation. So now you should not be worried with these three terms: a dimension, dimensional formula, and the dimensional equation. All of three are the kind of same dimensional equation, right? All right. So now here acceleration dimension A is dimension of LT minus 1 divided by dimension of t time, that is t. So this is how you are going to replace it. Now you cannot write it like this, or you cannot keep it like this. You need to write it down in the simple format. And what is the simple format? You need to have all the physical quantities, dimensions of the physical quantities in the numerator. So you could have written down like this, that the dimension LT minus 1 with multiplied by the dimension, and when this t goes in the numerator, the power will become t minus 1. So that's why the dimension of the acceleration is L t to the power minus 2. Wow! So we got the dimension of the acceleration. Isn't it quite interesting? Wow. Okay. So for today, this much only. The next lecture we will do the practice. Thank you.